All right, today we're going to do a full-on engineer's teardown of a really ambitious open source project called DeepCode. We're going to pop the hood on its architecture, see what makes it tick, what's clever, what's practical, and yeah, what challenges it still has to overcome.
So let's start with the big provocative idea here. I want you to forget about simple code completion for just a second. The question DeepCode is really asking is this. What if an AI could take a high-level goal, like a research paper, or even just a simple sentence, and then autonomously manage the entire process of building that software from start to finish? That's the promise we're digging into.
And there's a name for this whole paradigm. It's called Agentic Coding. And this definition is absolutely key. See, we're not talking about a passive assistant that just helps you out. We're talking about an autonomous entity. It understands, it plans, it uses tools, and it executes all on its own. It's a fundamental leap beyond the AI coding tools that most of us are using day to day. So the big question is, how does it actually pull something like this off? Well, the real magic of DeepCode, the core idea, is that it doesn't rely on one single monolithic AI to do everything. Instead, it builds a team of specialized AI agents that all work together, kind of mimicking the structure of a real, high-functioning engineering team. Leading this whole operation is the orchestrator. You can think of this as the engineering manager or the project lead. Its job is to break down that initial request and delegate tasks to the other agents. But its most critical function is dynamic planning. It can pivot, it can adapt, it can reassign work when things inevitably go sideways. And that right there is what separates a cool demo from a tool that might actually handle real-world complexity. So first up in the chain of command is the analyst. Its whole job is to solve that classic, vague stakeholder request problem that every developer has dealt with. It takes that fuzzy, ambiguous human language and translates it into a precise technical spec, a formal set of requirements that the other agents can execute against without making a mess. Next in the lineup is the specialist. And this is the agent that powers DeepCode's amazing paper-to-code feature. And honestly, this is super impressive. It can take a dense academic PDF, intelligently pull out the core algorithms and formulas, and structure all that information for implementation. For anyone who's ever tried to bridge that gap between a research paper and actual production code, you know this is a massive game changer. After that, we meet the architect. This agent's role is to make sure the final product isn't just a jumble of functional code that somehow works. No, it designs the overall software structure, it picks the right technologies for the job, and it lays out a clear development roadmap. In short, it makes sure the final code is actually well-engineered and maintainable down the line. You know how smart developers don't reinvent the wheel? Well, neither does DeepCode. The researcher and the librarian agents are tasked with scouring places like GitHub to find existing libraries and code snippets that can be reused. They analyze and index everything they find, building up a solid knowledge base specifically for the project at hand. And finally, we get to the coder agent. This is the one that takes the architect's blueprint, the researcher's findings, and puts it all together to synthesize the final code base. And what's very crucial here is that its job isn't over after just writing the core logic. It's also responsible for integrating the libraries and, get this, generating tests and documentation. It's aiming for what we'd actually consider a production-ready deliverable. So, if you zoom out and look at the whole thing, here's the entire workflow in 5 pretty clean steps. It's a nice logical pipeline: ingestion, planning, gathering, synthesis, and delivery. What's so smart about this is how it basically mirrors a very structured, almost waterfall-style development process. It makes sure that each stage has exactly what it needs before the next one kicks off. Okay, so we've got this team of super smart agents, but how do they actually do things? How do they search the web or read a file from a URL? That's where the system's, let's call it its nervous system, comes into play. It's a really cool piece of tech called the Model Context Protocol, or MCP. And I gotta say, from a pure engineering standpoint, this is a beautiful piece of design. MCP is basically an abstraction layer. It means the agents don't need to know the messy, low-level details of how to call some specific web API. They just say, I need to do a web search, and MCP handles all the plumbing. This makes the whole system incredibly modular and super easy to extend with new tools later on. So what's actually in this toolkit the agents get to use? Well, here are some of the foundational tools available through MCP. You've got web search, a tool to fetch content from a URL,
a file downloader, and even document segmentation. Think of these as the agent's senses and its hands. They're the basic building blocks that allow a purely digital mind to interact with the outside world.
Okay, now for the question that I know every single engineer watching this is thinking. This sounds amazing, but does it lock me into some expensive proprietary API? Can I run this thing myself on my own machine? Let's talk about taking DeepCode off-grid with a local large language model using Ollama. And the answer, amazingly, is yes. And it is surprisingly simple to do. Because of that excellent configuration-driven design we were just talking about, you don't have to touch a single line of Python code. You just edit one single YAML file, change the base URL to point to your local Ollama server, and that's it. You're done. Honestly, that's a huge testament to the project's really thoughtful architecture. But of course, it's not a free lunch, right? There are definitely some trade-offs. Your local model just might not be as capable as something like GPT-4, so you'll want to use the biggest one your hardware can handle. The built-in prompts might also need a little bit of tuning to work best with your specific model. And, it goes without saying, you're going to need some serious hardware, especially a GPU with a lot of VRAM to get decent performance. So after tearing this whole thing down, what's the final verdict? Let's pull all this together and look at the key strengths, the inherent risks, and what the future might hold for a project like DeepCode. So, let's break it down. The strengths are undeniable. The agentic architecture is genuinely sophisticated. The modular tooling through MCP is an engineering best practice, and the whole thing is beautifully designed around configuration. But the risks are just as real. Out of the box, it relies on paid APIs. It's an operationally complex system under the hood. And at the end of the day, you're always dealing with the unpredictable, black box nature of the large language models that power it. Now, what's really encouraging is that when you look at the project's public roadmap, it's clear the developers are keenly aware of these challenges. They're focusing on exactly the right things, improving code reliability, adding automated testing and static analysis, and even building a public benchmark to track performance. This shows a really mature understanding of what it takes to go from a cool proof of concept to a truly reliable tool. And all of this, it brings us to one final, really big question. DeepCode is an absolutely incredible blueprint. It's a major contribution to the open source community, and it gives us a very tangible glimpse into a future where building software could be radically different from how we do it today. So the question I want to leave you with is this. Are we looking at the future of software engineering? It's a pretty fascinating thought.